Hello all. So we're going to start out this week talking more about limits and how to actually calculate them without using a graph or a table. So get yourself ready to take notes and we're going to get started. So this first section from 2.3, we are going to talk about limit laws and calculating with a polynomial. Now, the things with limits, the nice thing about them is that most of the time, the limit as x approaches a of a function is just whatever that function is at a. So most of the time you can just plug in the number into the function and you're going to get the right answer. And what's also helpful is that if you get a weird answer for that, that's just a sign that we're going to use something else. So most of the time you can just plug in the number to the function, you're going to be fine. So if I asked you in this case, what's the limit of as x approaches 2 of x squared minus 1 over x minus 1? Well, let's just try plugging in. So let's take 2 squared as I plug in this value for both of our x's, minus 1 over 2 minus 1. Well, that's 4 minus 1 over 1, which is 3. And that is, in fact, the answer to this limit. If you don't believe me, feel free to go check on a calculator and come back and you'll see, oh, yep, as we approach on the graph, it's 3. As I look at the table, it's also 3. And this is because most functions are what's called continuous, which is something we'll be discussing in a later lesson. Now, sometimes you're going to get ones that turn out weird. And the nice thing is you'll notice this when you plug it in. So, for example, here it's the same function, but as x approaches 1. When I plug this in here, I get 1 minus 1 in the denominator. Oh no, if I have a 0 in the denominator, that means that this does not exist. Now, as we discussed earlier, just because something doesn't exist at that point doesn't mean the limit doesn't exist. So the limit might still exist, but the function doesn't. So what this tells us is just try to use algebra. Now there's two ways that you can use algebra in these types of problems. The first one is that we're going to look at for this lesson is just to use factoring. So we are going to factor this numerator. So we're still looking at the limit as x approaches 1 of x plus 1 times x minus 1, it's a nice difference of squares, over x minus 1. So we said we want to use algebra, we can cancel out the common factors. So this limit is equal to the limit as x approaches 1 of x plus 1. And now that we've done a little bit of simplifying, we can just plug this in again. So we'll use the same strategy, plug that in, and we end up with that limit is equal to 1 plus 1, which is 2. Again, if you want to check this on your calculator, please do. But what we have here is an example of where the function doesn't exist at a point, but the limit does. So here we're going to end up with the same issue. You'll be able to tell pretty quickly. You're like, oh, well, if I plug that in here, I get a DNE because I can't have 0 in the denominator. That's always what you want to be looking out for. So this is a sign that you want to use algebra. In this case, I am going to expand this numerator. So the limit stays the same. We're still looking at the limit as h approaches 0 of 3 plus h times 3 plus h minus 9 all over h. And then I get the limit as h approaches 0, and I'll FOIL this out, of 9 plus 6h plus h squared minus 9 all over h. And then, of course, the nice thing that we notice happens is that 9 cancels out, and these have a common factor. And when we have factors, we can cancel those out, leaving behind 6 plus h, and when we plug in that 0 to h, that just becomes 6 plus 0, which the limit is 6. So those are two different ways that you might use to simplify polynomials and limits. Let me know if you have any questions. Oh, I just realized that homework is off. Please don't go to 119. This should just be 19. All right. I'll make sure that that's correct in our sheets in the weekly plan as well as in the posts that you have. So have a wonderful day and don't do 11 through 119. I'll talk to you later. Bye.